What if I told you that space is not as silent as you think? Yes, you heard it right. The vast expanse above us, the cosmos, where stars twinkle and galaxies spin, is not as quiet as we have been led to believe. Now, you might be wondering, how is this possible? After all, sound needs a medium to travel, and space is a vacuum, right? Well, it's a bit more complicated than that. You see, while it's true that sound, as we know it here on Earth, can't travel through the vacuum of space, that doesn't mean space is devoid of sound. It's just that the sounds of space are not something our human ears can perceive. In space, sounds are created by different celestial bodies and their interactions. These interactions can generate electromagnetic vibrations, and these vibrations can be converted into sound waves that we can hear. For instance, the sun and other stars create a kind of hum by their vibrations. Planets, too, radiate noise. Jupiter, for example, emits radio waves that, when converted into sound, give off a series of eerie, ghostly whistles. So when we say space sounds, we're talking about these kinds of phenomena. It's a symphony of cosmic noise, an orchestra of celestial music, if you will, playing a tune that's both strange and fascinating. And it's happening all the time, right above us. This is the reality of the cosmos. It's not just a silent, empty void. It's a place filled with a cacophony of sounds, a chorus of cosmic notes that fill the vastness of space. It's a universe humming, whistling, and singing its own unique song, a song that we're just beginning to understand. So the next time you gaze at the night sky, remember, it's not as silent as it seems. The stars are singing, the planets are humming, and the cosmos is alive with sound. It's a symphony that's been playing since the dawn of time, a cosmic concert that's as mysterious as it is beautiful. Ever dodged a bullet? How about a cosmic one? Now that's a thought, isn't it? We may not realize it, but space is an endless battlefield of speeding bullets, except these bullets are meteors and asteroids. These cosmic projectiles hurtle through the vast expanse at mind-boggling velocities. We're talking about speeds that would make the fastest race car seem like it's standing still. Imagine this, a chunk of space rock, maybe the size of a small car, zipping past at 60,000 miles per hour. Now that's a sight, but it's not just the speed that's mind-blowing. These cosmic bullets pack a punch too. They possess the power to cause cataclysmic damage if they were to hit our planet. So the next time you gaze up at the night sky, remember this. The cosmos is not just a tranquil blanket of twinkling stars. It's a literal shooting range, and Earth is often in the crosshairs. In space, the bigger you are, the more you eat. Sounds strange, doesn't it? But this is precisely what happens in the cosmos. Galaxies, those vast, glittering islands of stars, gas, and dark matter, are not static entities. They're dynamic and often quite voracious. Imagine a galaxy as a grand celestial beast roaming the cosmic plains. When this beast encounters another, smaller one, it doesn't merely pass by. Instead, it swallows it whole, incorporating the smaller galaxy's stars and matter into its own body. This process is known as galactic cannibalism. It's a decidedly less gory affair than what we're used to on Earth, but it's no less dramatic. Larger galaxies grow and evolve by gobbling up their smaller neighbors, often resulting in beautiful and complex formations. So remember, out there in the vastness of space, size does matter. In the grand cosmic buffet, galaxies are both the diner and the dish. In the depths of space, there lurk invisible predators. Predators do not have a physical form you can touch or see, but whose presence can be felt by the havoc they wreak on their surroundings. These are the black holes, the dark predators of the cosmos. Black holes are areas in space where gravity is so strong that nothing, not even light, can escape their pull. They are born from the remnants of massive stars that explode in spectacular supernovas. The remaining core, if sufficiently large, collapses under its own gravitational pull, creating a point in space where gravity is so intense that it forms a hole, a black hole. But what makes these cosmic entities so predatory? It's their insatiable appetite. Once something crosses the event horizon, the point of no return, it's inexorably drawn in, stretched and torn apart by the immense gravitational forces, a process rather ominously known as spaghettification. And black holes are not just solitary hunters. They can be found at the heart of galaxies, including our own Milky Way, where supermassive black holes millions or even billions of times the mass of our sun lie in wait. These behemoths don't just consume stars and gas, they can also pull entire star systems or even smaller galaxies into their deadly embrace. Yet despite their fearsome reputation, black holes also play a crucial role in the universe. They help regulate the growth of galaxies and even aid in the formation of new stars. It's a delicate balance, a dance between creation and destruction. However, the existence of black holes also poses a potential threat. If one were to pass nearby, it could disrupt the orbits of planets, potentially catapulting Earth into a deadly interstellar journey. But don't lose sleep just yet. The chances of such an event occurring are incredibly slim, and our universe, vast as it is, still holds many mysteries to be discovered. Remember, in space, not all threats are visible. What if I told you there are particles passing through you right now? Yes, you heard it right. We're talking about ghost particles, or as scientists prefer to call them, neutrinos. These elusive specks are so tiny and so fast that they zip through matter as if it isn't there at all. Neutrinos are born in the heart of the sun, in the fiery chaos of supernovas, and even in the decay of radioactive elements. They are constantly shooting out in all directions, passing through everything in their path. That's right. Every second, trillions of these ghostly particles are passing through your body, through the chair you're sitting on, through the earth beneath your feet, and they do it without any interaction. These particles are a reminder of the incredible and sometimes downright eerie phenomena that exist in our universe. So remember, in the vast and mysterious cosmos, you're never truly alone, not even in the emptiness of space. Imagine a rain of diamonds. Sounds fascinating, doesn't it? Well, in the mysterious expanse of space, this isn't just a figment of imagination. It's a reality on gas giants like Jupiter and Saturn. In the depths of these planets, extreme heat and pressure transform carbon into a sparkling spectacle, diamonds. These diamonds, larger than the most extravagant ones found on Earth, aren't just a rarity, they're as common as rain. Picture this, a stormy, tempestuous sky, not with droplets of water, but with glittering gems falling from the cosmic clouds. A downpour of diamonds, if you will. But before you start planning a space expedition to mine these precious jewels, remember that the conditions on these gas giants are far from hospitable. High gravitational forces, extreme temperatures, and deadly storms make these planets a no-go zone. So while we marvel at the thought of diamond rain, it's best observed from afar. In the cosmos, even the weather is out of this world. Time travel is not just a concept of science fiction. In the vast expanse of space, time doesn't operate as we're accustomed to on our home planet. This is due to a mind-bending phenomenon known as time dilation, a real-life example of how time can warp and weave in the cosmos. Time dilation is a difference in the elapsed time as measured by two observers, due to a relative velocity between them or a difference in gravitational potential. It's a direct result of Albert Einstein's theory of relativity, which tells us that both space and time are intertwined into the same fabric of the universe, known as space-time. When we think of time, we often imagine it as a straight line, a constant progression from the past to the future. But in space, this line can curve and distort under the influence of gravity. The stronger the gravitational field, the slower time passes. This is not a mere theoretical concept, but a reality that has been experimentally confirmed. Imagine, for instance, a supermassive black hole, a region in space where gravity is so powerful that nothing can escape, not even light. If you were to approach this black hole, your perception of time would start to slow down relative to someone observing from a safe distance. From their perspective, your journey towards the black hole would appear to take an eternity. This time dilation isn't just limited to the vicinity of black holes. Even on the International Space Station, astronauts experience time slightly differently than we do on Earth. Although the difference is minuscule, the onboard clocks on the space station tick just a bit slower than their counterparts on Earth. So in a sense, astronauts are time travelers, albeit on a very small scale. Each day spent in orbit is a tiny step into the future. And while we're far from hopping into a DeLorean and zooming back to the past, the reality of time dilation in space gives us a tantalizing taste of the potential complexities and wonders of the universe. In space, time is not a constant, but a variable. Space has its own version of the undead. The cosmos holds many mysteries, and one of the most intriguing is the phenomenon of zombie stars. Imagine a star that has lived out its life, exhausted its nuclear fuel, and violently explodes in a supernova. Normally, this would be the end of the star's life cycle, but in some rare and extraordinary circumstances, these stars can come back to life. This resurrection is possible due to a process involving a companion star. After the initial supernova explosion, the star's core collapses into a dense neutron star. If this neutron star is close enough to a companion star, it can start pulling material from it. Over time, this accumulation of matter can trigger a second explosion, causing the dead star to reignite and shine once again. These zombie stars defy the conventional wisdom of stellar life cycles, adding yet another layer of complexity to our understanding of the universe. Even in death, stars find a way to shine. Imagine being a planet with no star to orbit. Welcome to the world of rogue planets, celestial bodies that break all our preconceived notions about what it means to be a planet. These solitary wanderers don't revolve around any star. Instead, they journey through the boundless darkness of space, untethered and alone. You might wonder how a planet ends up in such a lonely state. The story begins in a typical planetary system, where planets peacefully orbit their parent star. But sometimes, the gravitational forces in a bustling star system can catapult a planet out into the cold void of space. This might occur due to a close encounter with another planet, or perhaps a star passing too close. Suddenly, the planet finds itself ejected from the familiar warmth of its home star system, propelled into the vast cosmic sea. These rogue planets might seem like anomalies, but astronomers believe they could be surprisingly common in our galaxy. Some estimates suggest there could be up to 2 rogue planets for every star in the Milky Way. That's billions upon billions of lonely planets adrift in the darkness. But don't let their solitary existence fool you. These rogue planets are far from dull. They could potentially harbor subsurface oceans warmed by the planet's core, providing a potential habitat for life. Imagine life forms that have never seen a sunrise, creatures of eternal night. And even though these planets travel alone, they're not entirely disconnected from the rest of the universe. They still feel the gravitational pull of distant stars and galaxies, and they still partake in the cosmic dance, albeit from a distance. In the vast cosmic landscape, some wander alone. Yet, in their solitude, these rogue planets remind us of the incredible diversity and the mysterious beauty of our universe. They stand as silent witnesses to the cosmic drama, each with a unique story to tell, each challenging our understanding of what it means to be a planet. In the vast cosmic landscape, some wander alone. Space is not just vast, it's infinitely expanding. You've heard this before, right? But have you ever truly tried to wrap your mind around this concept? The universe, as we understand it, doesn't have a fixed size. It's not like a giant room with walls where you might hit a dead end. No, it's much more mind-boggling than that. Imagine you are on a ship sailing out into the ocean. As far as you can see, there's nothing but water. You keep sailing, expecting to eventually reach the edge. But the edge never comes. That's the closest we can get to visualizing the universe's expansion. It's not that the universe is expanding into something. It's that the universe itself is stretching, growing larger with every passing moment. This idea of an ever-expanding universe leads us to the concept of a never-ending void. It's like a cosmic game of hide-and-seek, where the hiding spots keep multiplying. The universe keeps getting bigger and bigger, and we, on our tiny little planet, are left to marvel at the endless expanse of cosmic wonders. On the one hand, this realization can evoke a sense of insignificance. After all, in the grand scheme of things, we're just a tiny speck in an unimaginably vast cosmic ocean. But on the other hand, it can also inspire awe and wonder. The universe is a grand stage where the story of existence unfolds, and we're privileged to be part of this cosmic drama. So as we journey through the cosmos, exploring its mysteries and marveling at its wonders, let's remember that space is not just a silent, empty void. It's a dynamic, ever-changing, and infinitely expanding entity. It's a place of beauty, mystery, and yes, a fair share of creepiness. In the grand scheme of things, we are but a speck in the infinite canvas of the cosmos. But remember, even the smallest speck can have a story worth telling.